Hello everyone, thanks for being here for this web talk about augmented reality on the web. Before starting, just a question, how many web developers are in the room? Okay, fine. Yeah, I hope you will enjoy this topic. Just before digging into the subject, just presenting myself, my name is Vincent. I'm a French software architect from Brittany. I work in an IT services company called S2I, and I'm also a Google developer expert around web technologies. And today we will see 4 parts for digging into augmented reality. I will start with the definition of the immersive web, how we can define it here. After we'll see how can we do augmented reality right now, and after we will dig into more in this new API and how can we play with it to make more immersive experiences. And last topic will be around UX and UI and how you can do progressive interfaces for this kind of experience. First, let's start with immersive web. Before giving the definition of what is immersive web, I want to restart with a quick definition around the 3 main topics in this area. Virtual reality. We all know what it is, but to be clear, it's an immersive or multimedia or computer simulated reality where you put your user inside, so you are in a complete digital environment. And on the other side, the most famous topic is augmented reality, and this one is having a real world live feedback of the real world and enhanced with computer-generated graphics, sound, video, etc. But it is just an overlay. And the real definition of what we have for a very powerful experience, like those we are going to see after, it's a mixed reality. It's the merging between real and virtual world where the user can interact with the products or the 3D graphics you are putting on the device. And the interaction is not the same between augmented reality or mixed reality and virtual reality. You can have a gamepad for both, and virtual reality you have a headset, and mixed reality, augmented reality, you can have phones or other kind of device. And the last 2 have constraints which are different from virtual world. The first one is they have to know the world relative to the viewer. In virtual reality, you are in the full web or virtual world, and in augmented reality, you see the live world, and you can't change this real world, and you can manipulate user and his space. You have to deal with it during your experience. And for an example for that is this cool demo made with ARKit, where you have a 3D model put in live in augmented reality, and when the user close the light, the model detects the light and change in dark mode, for example. So the final definition for immersive web is a mix of VR, AR, and the web, and how we can deal with all this kind of experience on the web platform. On the subject of VR and AR, Gartner last year said that virtual reality has come outside the through of disillusionment and mixed reality and augmented reality are just inside. And now, this year, they are outside of this part of the graphics, and they are now in a mature state where you can start dealing with it. There are, I think, 1 or 2 years before we can have a very powerful device, software platform like the web platform to have a big overview and can play with it more easily. And another statistics around the market in the next year will be very big in comparing the last 3 years. That's it for the definition. Now, how can we do augmented reality today in the web? Currently, the current ecosystem for the web is very big because we have millions of phones and tablets supporting AR. They all have web browser inside, so using the web platform is very easily as a definition of the power of the web as an open platform. The other advantages, so open, connected, you just have to send a link to a user, you open your experience and start playing with it. And you have instant feedback or instant connection. You don't have to go to a store, download an app, etc. And augmented reality can enhance your web page for a more powerful experience. You can create engagement with your user, empathy, and also action. We will see in more action later. And for example, on 3 main area, you have, for example, shopping with IKEA places. Is there anyone using this app now? So you can try it right now on the iOS and Android. I think you can just start using augmented reality for digging into all IKEA furniture directly inside your home. Education is very famous for discovering, for example, stars, etc. And entertainment, the big topic also for augmented reality. For education, for example, here is an example of Google displaying a web page like, for example, Wikipedia. And you are watching information about the spacesuit, and you want to see it live. And for example, if you tap on the bottom right image, you can start enhancing and using a near augmented reality experience and play with the suit directly and see live how it was created. The first way to do augmented reality today on the web is to use markers. There is a powerful library named AR.js for doing this kind of experience. Very fast. The main cons, it depends on the real marker. So you have to print something or to display something on paper, etc., for creating the experience. So I just do a little demo with that, and I am just trying to recreate IKEA places with just AR.js and a frame, which is a VR framework for creating VR and now AR experience. So on top of that, at the bottom we have the device camera and the physical marker, and on top of that we have a frame and between AR.js. So now, as you can see in this video, you have a marker on the floor, and you just have to put your 3D model it will follow where is it. But the main cons is if the marker go outside of the screen, you lose the reference, and the 3D model is not available. If you want to do this kind of experience with markers, there is this cool editor online to do easily and hosting your experience very fast. So you can check if you want. The other way is to use native frameworks provided by Apple and Google. ARKit for Apple and ARCore for Android. These native frameworks brings feature for the native platform, and the magic behind WebXR later we'll see that the API uses these frameworks inside, for example, Google Chrome, ARCore, and later ARKit on iOS. And you can use the feature of the frameworks directly by, for example, positional tracking of the phone, surface detection, light estimation, etc. There was people from Mozilla who just tried creating a custom and dedicated browser for augmented reality, which called Mozilla WebXR Viewer. It's just available on iOS, and there are open source versions for ARKit and ARCore if you want to start playing and doing some stuff with that. And they are just doing links between the native APIs and the JavaScript API you can use in a web browser. It's just for proof of concept, but it works fine. And I've redone the same demo using this browser and this viewer, and you now don't have to use markers and just use the native frameworks to detect the floor, for example, and after put your 3D model directly in your environment and start playing with it. So it's very easy and very funny to play. And now, the WebXR API is wrapper around these native frameworks, and it's here to enhance and give you the possibility to play with it more easily and on the web. Before starting and going inside, the WebXR API is just a reboot of an existing API called WebVR. Was started in around 2014, and it was a working progress API around virtual reality, and not supported everywhere, but in major platform, Android, Samsung Internet, or and then device for edge devices. And in 2017, when ARKit and ARCore were announced, there was in the WebVR community a main question about we are missing some people because of this graphic. With WebVR, we are just seeing the top audience and the little, very focused and little audience, and using 2D mobile screens for augmented reality experience, you can target more people. So they were very convinced that the web is a good platform for bringing this kind of experience more easily, because you can target all devices more in a more efficient way. So at the end of the year, they decide to rename the API to WebXR to bring VR and AR in the same API, and the community group was renamed Immersive Web Community Group. So what is this WebXR API? It's a no backward compatibility with WebVR, so you have to rewrite your WebVR application, but the port is very easy. It's a cleaner API. Since the last two years, there was many proposals, and now it's stable. We will see later. More compatible devices because you have VR headset and phones, etc. You support AR and VR in the same API, and it is more faster than before. The goal of the API is to give the possibilities to developers to detect available VR or AR devices, query the capabilities of the device, and after trying to play with the position of the device of the people for VR headset or for phones, and display the graphics on the device at the appropriate frame rate. So you don't you have to generate 3D graphics, and after the API will get and take these graphics and render them in the correct frame rate. For example, for VR headsets in 2 screens, or for augmented reality in 1 screen and at the correct frame rate. There is a draft available on this GitHub address, and you can see all the details and all the notes about the draft. There is also an online document around more discussion and state of the WebXR if you want more fresh updates. There is also a Prolify available if you want to try some projects, some experience in limited devices. The problem with all Prolify, if we can't Prolify, you can't Prolify everything. And for example, for augmented reality, if you don't have the native SDK, for example, ARCore on the device, you can't play with it with the Prolify. At the beginning, the API contains everything, and now they are separated in many modules. So now there are the low-level API, the WebXR, which is shipped in Chrome 79. There are also a WebXR gamepad module for dealing with a gamepad during, for example, a virtual reality headset, also shipped. And after, for the topics around augmented reality, ARCores, it testing, and the AR module are behind flags in Chrome. We will see some slides now around which code you can use to create this kind of experience. There is a lifetime and a sequence to deal with it. First, you have to check XR support of the device after requesting an XR session. When you have your session, you can start doing your render loop in your 3D graphics, and after the API will do the same thing on the device. After that, you can get some information about the position of the user, where is it, and the coordinates and the information about that. And finally, you can add anchors. We will see the demo later, and closing the session if you want. The API is hosted in the main global object navigator.xr, and after you have specific APIs to check for now if the device support. For now, immersive.ar, but you can check immersive.vr, etc. And if it's supported, the promise is resolved, and you have a boolean which gives you the information. And after you can start, for example, your session. After you have checked you are on a compatible device, you can request a session. For security reason and for many APIs now on the web, you need to have a user interaction. For example, clicking on the button, and after that you can call this API and request a session. After you get your session, you can save it locally and start to set up everything around the 3D graphics to start your experience. And prepare the rendering later on this station, on this function. For example, you can start by adding a callback if the session is closed by the user. We'll see later on the demo that you can the user can specifically say that it closed the session, or you can close it on your way. After, you have to create some 3D graphics environments. For now, a Canva with a WebGL context, and after linking it with the XR session. And the API, I've said that before, we will do the rendering on this way. And after, the other important thing is to deal with the context between, for example, virtual reality, or people is inside a virtual headset in a virtual world, or for example with augmented reality, or you have a local floor or level which is not the same. So they have put that in an API called reference space. So now you can request, for example, a local reference space for having information about where the user, for example, is located. And after, you can start the loop, the rendering loop, in the specific API request animation frame, which is the same as the window request animation frame when you want to do some work in sync with the frame rate of the screen. And after, when you are on this frame, you can start your rendering and recall the request animation frame each time. And during this rendering, after, you can play with the context where you are, the frame, the current frame of the people. Just missed maybe before to. Sorry. The XR ref space is an important thing during the code base, because you have to save at the beginning the first frame and the reference for having information about if the people have moved on the 3D world, etc. You can the API can do some calculation to give you information about the distance, for example, or where has it moved. So later, you can, for each frame, when you are rendering everything, you can get information about where is the viewer. So for that, you give the API the frame of reference, and the API will give you the current pose. And after, with that, that pose, you have to deal with, for example, if we are in VR, there are two views currently rendered. So you have to loop around these views and render everything. Or, for example, in augmented reality, there are just one view. And after, you can render your scene in 3D, and the API will display correctly it on the device. And last thing, you can here in this frame play with interactions, for example, gamepad, or many inputs the screen, or for example, gamepad. On this specific function, for example. Alors, last slide with code. You have to find the source, the API host input sources available. For example, the people or the device, the virtual headset, for example, has also a gamepad, etc. And people can interact with it. So you have to find the correct sources where you want to play. For example, here the screen. And after you have the pause of the current source, you can start, for example, placing, for example, a 3D model. And in this last function, I don't explain everything at the beginning, but the idea is to do some hit testing and in 3D. The idea is to when the user tap on the screen, you have information at the beginning where is the screen, and after the native SDK will do recasting to start finding the intersection of the line you have started when you tap on the screen and the local floor, for example. And after, if you get some hits coming from the API, you can start playing with it and let's put your, for example, 3D model directly on the 3D world. So, and after, you can close the session, get feedback for the closed session. So right now, you can play with it today, not directly for augmented reality, but also for VR. It's enabled in Chrome Beta 79. And all the flags around augmented reality are not enabled by default, but will coming more in next month. But you can't enable them very easily in Chrome. And so the last demo is around the same before, but with the WebXR API and a native web browser for now Chrome Canary, where you can easily do the same thing as before, but with more capabilities and not directly native APIs and not big libraries. I just used the 3.js for the 3D rendering. And you have this the same demo as before, where ARKit or ARCore for this demo has just have to find the environment and now the floor with the plane detection. And after you can put your 3D model and start playing with it as before, with just web APIs and a web address very directly. So now I will try to do the same thing live. So I will just give you a quick overview how you can do now this kind of experience. So I have a 3D model which is ready for interacting with you. So ARCore has detected the floor. I have a reticle ready for getting my input. So just now putting it, and if I stop playing, the model stop dancing, and if you applause a little, it will dance more. And if you stop, it will stop. Yeah. And you can play with it and go and see live that, sorry. The screen sharing has closed. Oh, you have seen the demo. Sorry, time is up, but there is a last part here around UX design in ER and in one slide, how you can do the same experience in augmented reality or on flat devices, and how do you have to deal with UI during this kind of three, for example, main device. There is also links for inspiration and, for example, Code Lab if you want to replay everything step by step. People from the community, some news and articles and a reference around the topics if you want to dig more in those topics, and also videos if you want to see more. That's for me. Thanks for listening.